Now we're going to do some work with exponential functions and we're going to transform them. So transforming exponential functions, sketching exponential functions, that's going to be our key for today. So when you start with an exponential, how do you know it's exponential first of all? This time the number y equals 2 to the power of x. So x is an exponent now. So you used to have things like x squared, right? That would be a quadratic. And now we have 2 to the x. So we're going to plot some points in order to find the sketch of the curve. And we're going to do that by just plugging in between -3 and 3 into 2. So we have 2 to the power of x here. This is what we're working with. So 2 to the power of -3. If you recall, it should be 2 to the power of 3 is 8, and the negative means 1 over it, 1/8. 2 to the power of -2 would be 2 squared is 4, and 1 over that. 2 to the power of -1 is 2, and 1 over 2. 2 to the power of 0, anything to the power of 0 equals 1. 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8. So if I go to sketch this graph now, I'm going to find -3 and an 8. That's really small. -2 and a quarter. -1.5. And the key point here, 0. And now it's going to go up really fast. 1 and 2. 2 and 4. 3 and 8. So my graph's going to look like this. Now what you should note about this function is that it also has an asymptote, just like the 1 over x graph has one. This one does as well. And that happens as we go to the left here, as I put in more negative numbers. Let's say I had 2 to the -100. Well, that's going to be something really small, right? It's going to be like 0.000. And well, we could do it on the calculator. What's 2 to the power of -100? My little calculator, and you can see 7.8860 times 10 to the -31. So I'd have to do an awful lot of zeros. But it's not 0 and it's not negative. So as we go to the left here, we have this asymptote here. We never cross this line. This is the line, of course, y equals 0 is the asymptote. So there's my function, y equals 2 to the x. Now let's talk about the transformations. It's a pretty easy graph to sketch and find a table of values. Of course, you could do it to 3 to the x, 4 to the x. Problem with those graphs and why you don't see them too often is obviously they go up very, very quickly. So if I start with 4, by the time I hit 4 to the power of 3, I'm already at 64. And it would not look nice on a little graph for you to sketch. So let's take a look at what happens here now. When I'm looking for transformations, remember that because we have y equals 2 to the x, it now means that any changes to x have to occur right here, right? This is where you're going to see changes to x in the exponents. Changes to x are up here. Anything else is a change to y. So let's just take a look at these 3 equations here that you're asked to draw, to sketch without graphing technology. And I should be able to pick out that this here, 2 to the x plus 1, that's a change to x. This is going to be a change to y. This one here, there's no change to x. It's still 2 to the power of x, but there's 2 changes to y. This one has changes to both of them. Hopefully you can see that the change to x would be here, and the changes to y's are out at the ends. If you remember that anything to do with a change to x has to be in the exponent, you'll be just fine. So what does this graph look like? Well, let's take a mapping rule for this. What happens to my x's and y's? So because this is x plus 1, you would say that that means that the graph is going to go to the left 1. So I'm going to subtract 1 from all my x's, and the y's are going to go down 2. So y minus 2. So what does this mean has happened? So it means a horizontal shift to the left horizontal shift left 1 unit, and a vertical shift down 2 units. As easy as that. This one, what would be the mapping rule for this? Well, x and y will go to, I do nothing to my x. You still 2 to the x. Now this is where people get confused because this 3 out front is a change to y. So look for your parent function. That would be the base with the exponent. Okay, look for the parent. And then everything else would be a change to y. So x, and I have 3y's minus 2. And so what does this look like? Well, I didn't do any horizontal changes. Horizontal, remember, that's x stuff, left and right. But I have 2 things that happen to the y's. I have a vertical stretch by a factor of 3, and I have a vertical shift down 2, and that's the mapping rule that we can apply to all the points. This one here, let's see, what do we have? What's going on here? Okay, so I double check, make sure there's no coefficient in front of the x. There isn't. It just says x plus 1. So that means I'm going to subtract 1. X's are weird, right? Plus 1, minus 1. What do I do to the y's? Everything out front. Minus y minus 2. What has happened to the graph? It has, oh, we have to state it in the right order. Oh, yeah, it's a negative y. So that means reflection about, okay, now if I'm changing the y's from positive to negative, it's about the x-axis. And I have a horizontal shift, right 1 unit. And I have a vertical shift down 2 units. Okay, you following along? So we've got all the main transformations here, and we have good mapping rules set up. So now it says table of values. Okay, so here, what is a point on to the x? So that gives me 1, 2, 3, 4 here. So I'm going to pick these 4 right here. So I'm going to do minus 1 and 1/2. I'm going to use 0 and 1. I'm going to use 2 and 4 and 3 and 8. And figure out what the next transformed point would be. So my x, I'm going to subtract 1. So all the x's, I'm going to subtract 1. So that gives me minus 2, minus 1, 1, and 2. And the y values, I'm going to subtract 2. So half minus 2 is minus 1/2. And 1 minus 2 is minus 1. 4 minus 2 is 2. And 8 minus 2 is 6. Okay, let's sketch that one while we're at it. So the asymptote, y equals 0. That was on the original function. How is the asymptote going to change? What will change the asymptote if it's here? So it's a y value, right? So if I change the y's up or down, so vertical shift of this is going to change your asymptote. So in this case, I have a vertical shift down 2 units. So this asymptote is going to be y equals minus 2. And you might want to draw that on your graph right away. Always dot it. And you should label it y equals minus 2. So that's where the graph is going to go to. So let's put on these points here. We have minus 2 and minus 1/2. Minus 2, minus 1/2. That's about here. I have minus 1 and minus 1. I have 1 and 2. And I have 2 and 6. 2, 3, 4, 5, 6. 2 and 6 is about here. So it means my graph's going to look like this. And there's my asymptote. Okay, so function notation here. Well, what did we do to the graph? So we'd say y equals, we did f at x plus 1. and we subtracted 2, where this was the parent function. Okay, so let's go on to this one here. We have, what did we have? We have some points here we're going to use. So let's see, we're going to do 3y minus 2. So let's start with, let's go from minus 2 this time. Just intuition. Minus 2 1/4, minus 1 1/2, 0, 1, 1, 2. Transform point. I'm not changing any of my x's. See that there's no change to the x, to the power of x. It's not to the power of 2x or to the x minus 1, none of that. So I still have the same point for my x, and my y I'm going to multiply it by 3. So that's going to be 3 times 1/4 is 3/4 minus 8/4. 3 minus, what did I say? It was 3/4 minus 8/4 is minus 5/4. And the second one, I have the minus 1, and I'm going to multiply half by 3. That's 3 halves minus 2. That's 3 halves minus 4 halves is minus 1 half. 0, nothing happens to the x again, and my y is 3y minus 2, so 3 minus 2 is 1. And finally, nothing to that one, and 6 minus 2 is 4. So what happened to my asymptote? So I look, the asymptote is right here, right? Here's the asymptote. Minus 2, minus 2, minus 2. They're all minus 2 in this case because we've shifted the graph down 2, and the asymptote is a y asymptote. So if it goes down 2, it goes down 2. So this also has an asymptote of y equals minus 2, and so does this one while we're at it. Okay, so I sketch in my minus 2 again. Y equals minus 2. I plot my points. Minus 2 and minus 1 1/4. That's just kind of about there. Minus 1 and minus 1/2. 0 and 1. 1 and 4. 1, 2, 3, 4. So here's my graph like this. It's coming down like that. Same asymptote. What's the function notation this time? Well, I had 3. Let's go up here for a second. So I have 3 times the function, which is 2 to the x. So 3 f at x minus 2. 3 f at x minus 2. And finally, this one here. So point on the graph, we're going to do x minus 1 and minus 1 minus 2. So let's just use the minus 1. If you're like me, try to avoid the fractions as much as possible because that's probably where you're going to make a mistake. Okay, so transform point. Minus 1 more is minus 2. 0 minus 1 is minus 1. 1 minus 1 is 0. 2 minus 1 is 1. So I got all my x's set up. Now I'm just going to follow the rule for the y. So it's going to be a negative 1/2 minus 2. That's minus 2 1/2. Minus 1 minus 2 is minus 3. Minus 2 is minus 4. Minus 4 minus 2 is minus 6. Okay, so they obviously made a nice job of setting the graph up for us here. We have the same horizontal asymptote, y equals minus 2. Remember, you're just going to see that right on the equation. It's very straightforward. Okay, so I have minus 2 and minus 2 1/2. So that's right about here. I have minus 1 and minus 3. Minus 1 and minus 3. 1, 2, 3. Minus 1 and minus 3. I have 0 and minus 4. And I have 1 and minus 6. So my graph's going like this. Now notice it's been reflected about the x-axis. So the graph that was here got flipped this way, then shifted down and shifted left. So what was the function notation for this one? So I have negative f at, can you see the top one? Negative f at x plus 1 minus 2. Okay, where this was our basic function. So finally here, we're just going to state the domain and range, and I'm going to leave this and do something more difficult with the next lesson. State the domain. Well, I can put in any value for x and get an answer for y. So that means the domain is x is an element of real numbers. And the range, it starts at -2, but it doesn't go there. So I have to say it's going to be y is greater than -2. Can't be equal to it because we never touch this line. Y is greater than -2. Y is an element of real numbers. This one, domain, same thing. Domain, x is an element of real numbers. What is the range? It starts here and goes up, so it's the same range as the last one. Y is greater than -2. And the last one, this is the tricky one because it's going down. So my domain is still going to be real numbers, but my range is going to be y is less than -2, not greater than this time, less than because it's all under here, and y is an element of real numbers. I'll do more difficult ones in the next lesson. This is a very tricky lesson, so make sure you pay close attention, and good luck with your studies.